Hello everyone, welcome to our 7th lecture of Fluid Mechanics and Hydraulic Machines. This subject is offered in mechanical engineering and also for civil engineering students, that is the fluid mechanics and hydraulics. Today we are going to start our new topic, that is the measurement of pressures. The unit name, that is fluids and their properties, or we can say is the fluid static, that is the second module in civil engineering. So if we talk about our previous session, means lecture number 6, at that time we had discussed about the hydrostatic law, that is the pressure variation in a fluid at a rest, which law that states us the rate of increase of pressure in a vertically downward direction that must be equal to the weight of fluid at that point. By that law, we concluded that the P, which is the pressure intensity, that equals to rho GH. So that was all about our previous session, which was the hydrostatic law, and that is the very much important for our examination point of view. So you must go through that our basic introduction of this fluid static, and by that hydrostatic load we concluded the pressure P that equals to rho GH, where your rho, that is the density of fluid, G, that is your gravitational acceleration, and Z, which is your height. Okay, so let's move forward towards our this current topic, which is the measurement of pressure. So in this topic we'll cover the different classification, or we can say is the measuring instrument which we are using for the measuring the pressure at various levels. So let's start our classification. First of all, mainly we can classify these pressure measuring devices by these two type, in that first one which is different types of manometer, and second one that is our mechanical gauges. And this one is also the IMP topic for the examination point of view. There is a lots of questions in this YouTube manometer, YouTube differential manometer, and also the examples they are asking based on this YouTube differential manometers. As far as theory concerned, the burden tube pressure gauge is the important question for this examination, and also this bell law pressure gauge. So let's start. What is these different types of pressure measuring devices, and how can we use these different pressure measuring devices? So let's start our this lecture. In this session we'll cover only this classification, and very next lecture, I mean the lecture number 8, will cover in detail all about these manometers. So first one is manometer. Okay, again this manometer is classified in piezometer. This manometer is used to measure the pressure of different flows. In this classification, first one is piezometer. So in this diagram you can see the figure of piezometer. This one is your glass tube, vertically glass tube, which is held in this pipe, and here it is the cross section of pipe A. So if you want to find out the pressure intensity inside of this pipe, so simply you have to connect this piezometer tube. This one is glass tube, transparent glass tube. So we have to connect this piezometer glass tube with this pipe where you want to measure the pressure. Suppose I want to measure pressure point at A, so we are going to connect this piezometer tube at a point A, which is the parallel to the point A, and the fluid which is flows through this pipe A. Okay, so here it is the cross section of pipe A. Simply in this piezometer tube we need to measure the height h, which is the rays of liquid in this piezometer. So by taking the value of this h, we can put this value in this equation, that is P, pressure intensity at a point A, that equals to our rho GH. So this was about our hydrostatic law. Pressure P that equals to rho, which is your density of this liquid, G, that is our gravitational acceleration, and the H, which is the rise of a liquid in this piezometric tube. Okay, so by this equation you can find the pressure intensity at a point A. So this was about our piezometer. And the next thing, we have a YouTube manometer. In this YouTube manometer, here it is the one a cross-sectional pipe A again, and the glass tube which is now in the form of a U. So by this formation of U, the name is a YouTube manometer. So in this YouTube manometer, over here you can see that heavier or the dense liquid which has a higher viscosity compared to the flowing fluid. Means if you have a fluid or a water which is flowing through the pipe A, let's say the water which is flowing through this pipe A, so you need to have a heavy fluid compared to this water. So in this case, always we are taking as a mercury as a heavy fluid in a YouTube manometers and a YouTube differential manometers. So first thing, you have to find out the pressure of this water which is acting on this mercury level. This pressure is acting on this mercury level. So here it is the datum or the reference for this mercury, and over here it is the rays of mercury which is H2. Because of pressure of water, there is a downfall in this left limb which is H1. So this downfall in the left limb which increases the height of mercury at this level, that is your H2. So by taking the difference of these heights, we can solve the pressure, or we can find out the pressure intensity in the pipe A. So we will discuss in detail all about this YouTube manometer. So here it is only the introduction of this YouTube manometer. Next one, that is the single column manometer, and this single column manometer which is again classified in two types. First one is vertical single column manometer, and second one that is inclined single column manometer. So in this diagram you can see that the vertical single column manometer, in this vertical single column manometer, this one is your vertical single column manometer. We have one reservoir. This one is your reservoir which is filled with the pressurized fluid which we are going to find the pressure, and the second one is the heavier fluid compared to this flowing fluid. This one is your heavier fluid, means mercury is there. Okay, so by the small distance over here, there is a small change in a pressure in this reservoir which is reflected to the higher height, which is reflected to the higher height of this right limb, that is the H2. So the main application and the use of this single column manometer is that where there is a small changes in a pressure in your fluid, so to measure the small changes and the small variation of pressure, we need to use this single column manometer. This one is your vertical type single column manometer, and if we say the inclined single column, there is a more increases in a sensitivity of this inclined column manometer. So over here that is somewhat like that, the inclined column manometer. This vertical limb is replaced with this inclined limb like this. Okay, so this was all about our vertical and the single column manometer. Again, we will discuss in detail about this single column manometer and inclined column manometer. Okay, so no need to worry about that. Next is the YouTube differential manometer. So previously in a YouTube manometer, there was a limb like same as like this. So in that YouTube manometer, there is a only one pipe was there, which we are going to find out the pressure inside of this pipe. But in this differential manometer, it is again a YouTube manometer, but it is the differential manometer, YouTube differential manometer, which is basically used to measure the pressure between these two pipes, which measures the pressure between two pipes. So in this single YouTube manometer, which we are using to measure the pressure in only one pipe. Okay, so basic difference between these two YouTube manometer and YouTube differential manometer is that in YouTube manometer there is only one pipe, and in YouTube differential manometer where we are going to find the difference of pressure between these two pipe. If you have multiple pipes in your plant or in your working area, at that time we need to find out the pressure difference between these two pipes. So here it is the YouTube differential manometer. Next type of manometer, that is inverted YouTube manometer, that is inverted YouTube differential manometer. So here it is the diagram for inverted YouTube. You can compare this one is YouTube and this one is your inverted U, I mean the reflection of this U. So this one is your inverted YouTube differential manometer. Differential, that means again there is a two pipes where we are going to find the pressure difference between pipe A and the pipe B, and yes, it is the inverted type. So if you are going to find the pressure difference or a minimum pressure difference where there is a lower viscosity or a lower density of fluid or in a vacuum side, at that time we need to use this inverted YouTube manometer. Okay, and our yes, it was the last for this manometer. So there is a manometer. First manometer is piezometer. Second one, that was a YouTube manometer. Third one, that was a single column manometer, YouTube differential manometer, and inverted YouTube differential manometer. So there is a 5 types of manometers which we are using to find out the different pressure or the pressure difference in every field of engineering. Okay, and the next classification of this pressure measuring instrument, that is our second type, which is mechanical gauges, which is direct measurement instrument where we did not find out any numerical or any formula to find the pressure difference. So in this mechanical gauges, our first gauge, which is the burden tube pressure gauge. First one, which is burden tube pressure gauge. So live application, we say the application of this burden tube pressure gauge when you are going to fill the air, pressurized air in your motorcycle or in a car. At that time they are using one pressure instrument or a pressure device by which they are measuring your current pressure or existing pressure of your tire. So that is the same as our burden tube pressure gauge, where there is a one elliptical tube like this one is our elliptical tube. This elliptical tube which is connected with this sector by means of these linkages, and this sector is rotate this pointer by the gear mechanism, and this pointer is shows our the current reading of your pressure. So simply where you are going to find out the pressure, at that time we need to connect this line with that pressure line, and pressurized air is goes inside this metallic tube, and this tube is deflect due to the higher pressure of air. This elliptical metallic tube is deflected, and by deflection of this metallic tube is deflect your sector, and this sector is directly connected with this pinion by gear mechanism, and on that pinion there is one pointer which shows the different reading of pressure in your dial, on your dial. So this was about your burden tube pressure gauge. Okay, so this one is your burden tube pressure gauge. Our next device, that is the diaphragm pressure gauge. This diaphragm pressure gauge, when your pressure is increases from this bottom side, this one is your diaphragm. You can see in this figure there is your diaphragm which is got expanded in your upward side, and when this expand in upward side, one rod which is connected with this diagram which moves upward side and connected with this pointer, and this pointer is shows you the reading like this over here, that is 10 bar, over here that is 20 bar, over here which is 30 bar, and directly it shows your reading. So over here that is one diaphragm which is deflect your diaphragm, and directly shows the reading of your pressure. Okay, so it is your diaphragm type pressure gauge. Third one, that is the dead weight pressure gauge. In this dead weight pressure gauge, we need to put over here a weight W of 10 kg, 20 kg, and by putting this weight, the pressure gauge is shows you the current pressure. So this was our third type, dead weight pressure gauge. And the fourth one is bellow pressure gauge. Your bellow pressure gauge, where your pressure is inside, pressure is inlet at this way, and which deflect your bellow, and by means of deflection this pointer is directly shows you the current pressure of your system. Okay, so this one is your mechanical linkage which is connected with this pointer by the gear mechanism. There is one a spring resistance which again your original position. Okay, to take original position of this bellow. So this use of spring is to regain the original position of this bellow. Okay, so this was all about our classification of pressure measurement devices. These all are the most IMP topic of pressure measurement devices. In our laboratory experiment, we'll use this YouTube differential manometer to measure the pressure difference between 2 points or individual point. Okay, so let's start one by one our pressure measurement devices. In that, our first and the basic question, that is the manometer. Yes, and there is a principle of manometer. So what is the principle? When your piezometer means this one is your vertical glass tube, that is your piezometer. Okay, so when your piezometer is used to measure the liquid pressure in a system by measuring the height to which a column of the liquid rises against the gravity. Means whenever you want to find out the pressure in any pipe, at that time you need to connect this piezometer at that point. Like in this figure, it is connected with a point A. So from this point A, when you are taking the height from this point A, vertical height against the gravity, and this height shows you the height of or the rise of a liquid in your piezometric tube. So the raise of liquid gives the pressure head. This raise of liquid gives you the pressure head at that point, and the pressure that equals to P, that equals to rho GH as per our hydrostatic law, where rho is the density, G is the gravitational acceleration, and the H, that is the raise of a liquid in a piezometric tube. This one is your raise of liquid in a piezometric tube, because this one is your pressure, and the pressure unit of pressure, that is your Newton per meter square. Okay, so this one is your principle of manometer. This question is asked in examination by 3 to 4 marks. What is the principle of manometer? Explain with need sketch. Okay, so thank you. That was all about our today's lecture. For the task of today's lecture, you need to write down all the classification. When the question is classification of pressure measuring instrument, you need to write down this classification. After that, you have to write the principle of manometer. Okay, and then submit this task to your Google Classroom. Thank you.